this is our project. We focused on the conditions during forest fires, focusing on wind, temperature, and relative humidity. My name is Temple Corbett, and we also have Kelsey Kauflin, Yasmin Lusaif, and Nate Turkoff. So a little bit of background about our topic. Forest fires usually affect the preservation of the forest, which can create economical and ecological issues for both humans and the environment, and cause general human suffering in terms of death. So we decided to focus on the forest fire data, specifically from the northeast region of Portugal in the Montesino Natural Park, in the Bragança and Vinhais area, which suffered a lot of drought during March and September, specifically of 2007, which resulted in around 830 forest fires with around 8 human deaths. As we know, dryness plus heat can equal fire. So our research question was, how did the conditions of forest fires compare in March and September of 2007?
So the variables that we focused on were wind speed, relative humidity, and temperature in 2007. And these data are relevant because they are all possible contributing factors to the large difference in number of forest fires between March and September. And all the conditions were measured using standard weather instrumentation. I think they probably took it from the weather data or whatever. And then the report, it does not mention any external factors that could have affected the collection of these data, but it's probably something like machining differences. And then the collection effort of this data and the actual data itself, we found were to be appropriate for this question. All right, so our first parameter of interest are the wind speeds from March and September, and then these histograms here show the data to be approximately normal. And for this test, we used a 2-sample t-test with our hypothesis being that these two have the same mean, and we'll reject it if the p-value is underneath 5%. All right, so the mean for March wind speed was 5.01 kilometers an hour, and September wind speed of mean was 3.74. And running through that test, we found a t-value of approximately 3.9, which is far greater than the t-value of alpha, which is at 1.6. And the p-value at approximately 0 is far lower than 0.05. And that leads to a rejection of the null hypothesis, meaning that March wind speeds were on average higher than September. And looking at this box plot, the medians show the same, roughly the same thing as well. They're significantly higher.
Okay, so now we're comparing relative humidity measured in percents. So first, we'll look at our histograms for this one's March and this one's September, and they're both approximately normal. So we used a t-distribution. Our parameter of interest is mean relative humidity during March and September forest fires. We had our null hypothesis as mu1 minus mu2 equals 0, and our alternate hypothesis as mu1 minus mu2 is greater than 0. And we're doing a 2-sample t-test, and we're going to reject if t naught is greater than t at alpha and the correct degrees of freedom, and if the p-value is less than 0.05. So for descriptive statistics, sample 1 is September and sample 2 is March. Both had sample sizes of 50. The mean for September was 42.6 and the standard deviation was 15.6. And then for March, the mean was 40.2 and the standard deviation was 17.5. So for our tests, we got a t-value of 0.73, 96 degrees of freedom, and a p-value of 0.234. So since the t-value is less than t at 0.05 and the 96 degrees of freedom, we're going to fail to reject, and also the p-value is 0.234, which is greater than 0.05, and so we're going to fail to reject from both ways. Relative humidity during forest fires of March versus September is not significantly different. And then we have our box plots for March and September. And so we can see the medians are also really similar. There is an outlier for March that could be affecting the mean in our test, but since the medians are still pretty similar, we didn't really take the outlier into account.
The next condition we wanted to look at was the temperature. As you can see, both histograms show a somewhat normal distribution. We assumed it's completely normal. And the parameter of interest we looked at was the mean temperature during September versus the mean temperature during March forest fires. Our hypothesis was that the difference between both mean temperatures was 0, and the null hypothesis was that it was more than 0. We chose T naught and delta naught as our test statistics, and then we chose to reject the null hypothesis if the T naught is more than T alpha divided by 2, or if the p-value is less than 0.05. Both of the samples we chose to look at had a sample size of 50. For September, we found the mean of the sample to be 19.66 degrees Celsius, and then for March it was 13.08 degrees Celsius. The standard deviation for September was 4.84, and then the standard deviation for March was 3.24. So when we ran the test, we got a t-value of 7.99, 85 degrees of freedom, and a p-value of almost 0. So since the t-value was more than 1.6609, and the p-value was less than 0.05, we chose to reject the null hypothesis, showing that the temperature during forest fires of September is significantly different from the temperature during forest fires in March. And then if we look at the box plots comparing the temperatures in September versus March, we can clearly see a huge gap between the median for September versus the median for March. So just to conclude all of our results from our t-tests, we found that the wind speed is significantly higher in September than in March, and we also found that the temperature is significantly higher in September than in March. However, we found that the relative humidity is not significantly different between the 2 months, and we suspect that the difference could have been skewed because of a couple of outliers in the March data sample. And then looking back at the main data set, we have noticed that there were more forest fires in September than in March. So from our samples, we concluded that the temperature as well as the wind speed were higher than those in March. And we suspected that the temperature and wind could be the driving factors behind the higher number of forest fires. However, further investigation needs to be done to determine the correlation and the possible causation between the temperature, wind, and the number of fires.